So, a very good morning and welcome to today's class.
Good morning.
Good morning, and today's class will be on refraction. Refraction. What do you mean by refraction? Any idea? Up till now, what was happening? That we had a boundary. This was boundary between two mediums, or it was a reflecting surface, and a ray of light was falling onto it. We call it the incident ray. This was the angle of incidence I, and what was happening was it was getting rebounded back into the same medium. This phenomena is known as reflection of light. It was coming back in the same medium. But what can also happen is that this ray of light, instead of bouncing back into the medium, it can also go into the second medium. It can also go into the second medium. That means it passes from one medium to the other medium. This phenomena, when light moves from one medium to other medium, the speeds of light in different mediums are different. So light travels fastest in vacuum, but in any other medium, the speed is less. The medium in which speed is more is known as rarer medium. Have you heard the term rarer medium? Rarer medium. Rarer medium is a medium where speed of light is more. Then we have denser medium, and in a denser medium, the speed of light is less. The rarest medium, when I say the rarest medium, I mean the medium where light is fastest, speed of light is fastest. Which is the rarest medium? Which is the medium in which the speed of light is fastest? Any idea? Anyone knows which is the rarest medium? It is vacuum. Vacuum or free space. This is the rarest medium, and speed of light is fastest. This is known as the rarest medium, and the fastest speed of light in this medium is 3 into 10 raised to the power 8, approximately meter per second. Now, when light goes from one medium to the other medium, its speed changes. When light travels from one medium to the other medium, its speed changes. Because of this change in speed, the light bends. What do you mean by the bending of light? If I just draw a diagram, just showing you the incident light, this is, let us say, the incident ray. Do we all see this? Do we all understand this? This is the incident ray. Do we all understand this? Now, if it just goes like this, straight, it goes straight. It just travels in a straight line. Nothing happens. Now, two things can happen here. Either it goes like this, the red one, or it goes like this, the green one. What is the difference between the red one and the green one? You have the mic, it is working, right? What is the difference between the red one and the green one?
denser medium difference.
So basically, in simple language, this is bending towards the normal, and the green word is bending away from the normal. So two things can happen. Either the light ray can bend towards the normal, or it can bend away from the normal. This phenomena, when light travels from one medium to other medium and it bends, this phenomena is known as refraction. Whether it bends towards or away, we will see that. It depends on the medium, but this phenomena where light, when traveling from one medium to the other medium, it bends. This bending of light is known as refraction. And what is the reason of this refraction? Why does the light bend? Why does the light refract? It is because of difference in what?
Denser medium.
Difference in the speed of light in the two mediums. This phenomena of refraction happens because of difference in the speed of light in the two mediums. Difference in the speed of light in the two mediums. If it is a rarer medium is a medium where speed of the light is more, whereas the denser medium is the medium in which the speed of light is less. Do we understand this?
Yes, sir.
I'll give you a minute to note it down. Now take your attention back to the notes, the sheet that I have sent you. This sheet specifically tells you what I've already spoken. What is refraction? Refraction is the phenomena in which, other way of saying it, the direction of propagation of light changes at the boundary when it passes from one medium to the other medium. We understand this?
Yes, sir.
The speed of the light changes. What all things change and what all things don't change? If you remember reflection, speed remains same, frequency remains same, and wavelength remains same. The only thing that can change is probably the phase. If it is getting reflected by a denser medium, phase changes. The other thing that can change is the amplitude. If the entire wave is getting reflected, the amplitude remains same. If a part of it is refracted or absorbed, then the amplitude suffers. But wavelength, speed, and frequency remain same. Do we understand this? In case of reflection, all the three things remain same. Yes or no?
Yes, sir.
Now the question is, what all things out of these three changes or remains same in case of refraction? In case of refraction, remember the frequency of the light does not change. The frequency F, it does not change. Remember, frequency of the light is determined not by the medium, but by the source that is emitting that light. If that source is same, the frequency remains same. Do we understand this? If, for example, this is my source of light, you can see it's reflecting some light. If this is my source of light, unless and until I change this source into something else, the frequency of the light remains same. Do we understand this?
Yes, sir.
Now the frequency of the light remains same, and you must remember the relation between frequency, wavelength, and velocity. Do we remember that? Frequency, wavelength, and speed. V is equal to F lambda. Do we remember this relation? If not, please note it down. F remains
Okay, sir.
same. F
Yes,
remains
sir.
same, but V means the speed of light. When it goes from one medium to other medium, is the speed of light same or different?
Different.
Different, but frequency is same. Now velocity has changed, but the frequency has remained same. That implies that one thing again will change. What is the other thing that will change when light goes from one medium to the other medium?
Wavelength.
Wavelength will change. That means when light travels from one medium to other medium, the speed and the wavelength changes. The frequency remains same. Because of speed of the light changing, it bends and it moves from one medium to other medium. Sometimes it bends away, sometimes it bends towards, sometimes it bends away. This phenomena is known as the phenomena or the concept of refraction. Do we understand this?
Yes, sir.
Then there are two laws of refraction. Remember, these laws of refraction are pretty similar to the laws of reflection. The first law of reflection was the incident ray. It was reflected ray then. Now it is refracted ray, and the normal always lie in the same plane. Do we remember that law of reflection?
Yes, sir.
The second law of refraction is similar to what was there. In the laws of reflection, we saw that angle of incidence is equal to the angle of reflection. Yes or no? That was the second law of reflection. Yes or no?
Yes, sir.
But here they are not same because light is going to bend away, but they are related to each other. How they are related to each other? I can write this as mu I into sine I is equal to mu R into sine R. What is mu? We will understand this. I'll give you 2 minutes to write these two laws of refraction. The second law of refraction is the product of refractive index. What is refractive index? We'll come to know. And the sine of the angle of incidence is a constant, or the product of refractive index into angle of incidence, sine of angle of incidence is a constant. I'll give you a minute to note this down. Let's move ahead and see what the second law. First law is pretty simple. What the second law actually means, and I'll try to make you understand. Please have a look. Let us assume that this is the boundary between two mediums, and this is my normal. We all understand this, yes or no? This is the incident ray. The angle of incidence is I. Let me assume that this is the refracted ray and the angle of refraction is R. Now, angle of reflection was also called as R. If you also call angle of refraction as R, you might get confused, but all the books and everyone it is written as R. I will sometime write it as T. T stands for transmission. Refraction and transmission are one and the same thing. Do we understand that? Do we understand that?
Yes, sir.
Okay. So instead of R, I might sometimes use T, but here I will just use R. So this is the angle of refraction. Now the blue one is the incident medium. I call it medium number 1. Now instead of calling it medium number 1, I call the refractive index as mu I. Mu standing for refractive index. What is refractive index? Just hold on, I'll let you know. I standing for the incident medium, and the refractive index of this medium is mu R. Mu standing for refractive index, R standing for the second medium. So what does the second law say? The second law simply says that if I take the product of mu of the medium and I multiply it by the sine of the angle of incidence, that is a constant. Do we understand this? If I apply this
Sir.
law, If I apply this law on medium number one, or incident medium, it will be equal to mu I into sine of I. Can I have some raised hand that we understand this?
Yes, sir.
That will be equal to, if I write it as mu R into sine of R. Do we understand this? Mu R is the refractive index in the second medium or the refracted medium, and R is the angle of refraction. Do we understand this? So I can write this law in this way also. Sine of I divided by sine of R is equal to mu of R divided by mu of I. So either you write it like this, equation number one, or you write it like this, or you write it like this. We all mean the same thing. Is it clear to everyone?
Yes, sir.
I'll give you a minute to note it down. The only thing that is a bit confusing is what is mu. We will discuss mu once you write this thing down. Well, now is the time that we understand what do you mean by refractive index. Now this refractive index can be defined in two ways. The first way is we can define it in terms of absolute refractive index. Now before moving any further, we must understand that this absolute refractive index is defined by the speed of light and the speed of light in any other medium. Now speed of light is fastest in vacuum, so the absolute refractive index of vacuum, absolute refractive index of vacuum is taken as 1. Do we understand this? The refractive
Yes, sir.
index of vacuum is taken as 1, and refractive index of any other medium, it cannot be less than 1. It's always more than 1 for any medium. Do we understand this?
Yes, sir.
Okay. Now, how is this refractive index defined? Well, it is defined as the ratio of, this is the ratio, speed of light in free space means vacuum, to the speed of light in the given medium, or absolute refractive index of any medium, mu m standing for medium, is equal to the c means speed of light in vacuum, divided by vm means speed of light in the given medium. Do we understand this?
Yes, sir.
Denser is the medium where lesser will be the speed of light, and so greater will be the refractive index. If the speed of light is less, the ratio C by V will become more, and hence that medium becomes a denser medium. Speed of light in glass, as an example, is less than the speed of light in water. Light travels faster in water compared to glass. Therefore, the refractive index of glass is more than refractive index of water. Water is a rarer medium. Glass is a denser medium. Do we understand this?
Yes, sir.
So refractive index tells us how fast light moves in that medium. Light is the fastest in vacuum. Refractive index of vacuum is 1. Refractive index of any other body will be more than 1. If the refractive index is high, it will always be more than 1. For example, we have two mediums. The refractive index of medium number 1 Oops, why I'm using this? The refractive index of medium number 1 is 1.5. The refractive index of medium 2 is, let us say, 2.5. That means medium 2 is denser, medium 1 is rarer. Where will the speed of light be more? Where will the speed of light be more? In medium number 2 or in medium number 1? Tell me.
Rarer medium.
Which is the rarer medium? Tell me. 1 or 2? There are only two options here. Either it will be 1 or it will be 2. Where is the speed of light more? The yellow one or the blue one? Where is the speed of light more?
One.
Medium 1 or
One.
medium 2? And the answer is medium 1.
One.
Medium 1 is rarer medium, speed of light is more. Medium 2 is denser medium, speed of light is less. Is it clear to everyone?
Yes, sir.
I'll give you a minute to note it down. Well, now we are going to move forward and understand one more term, and this one more term that we are going to understand is known as relative refractive index. Now, what do you mean by the term relative refractive index? Now, what is wrong with this pen? Why is this pen not working? Okay. Are? Are? Something is definitely wrong. Okay, let us leave it here. Now, what do you mean by this term relative refractive index? I was trying to highlight it, but sometimes this machinery stops working. Relative refractive index. Now, when I said absolute refractive index, and I wrote it like this, mu of the medium, yes or no? That was the absolute refractive index, and I wrote it like this: c, the speed of light, divided by vm, which is the speed of light in the given medium. Now that absolute refractive index is also a type of relative refractive index. The only difference is that refractive index, the absolute refractive index, is defined with respect to vacuum. So I can write the word V on the top. Now, once I write this term V on the top, it basically means this is the refractive index of medium, and on V is on the top. This is the refractive index of medium with respect to vacuum. Do we understand this? So it becomes a relative term. It becomes something like relative velocity. Velocity of A with respect to B. Refractive index of A with respect to medium. With refractive index of medium with respect to vacuum. Do we understand this?
Yes, sir.
Now, instead of vacuum, if I use any other medium, so I can write it like this: mu of 2 with respect to 1. Do we understand how I've written this?
Yes, sir.
Look at that pink highlight. What does that pink highlight mean? Refractive index of medium number 2 with respect to medium number 1. Do we understand this?
Yes, sir.
Now that is simply equal to refractive index of 2 with divided by refractive index of 1. Remember, when I write mu2, that is the refractive index of medium 2 with respect to vacuum. Mu1 is the refractive index, absolute refractive index of medium 1, which is nothing but refractive index of 1 with respect to vacuum. Do we understand this?
Yes, sir.
So mu of 2 with respect to 1 simply becomes, in the bracket, in the square, mu2 divided by mu1. When I write the value of mu2, it will be c divided by v2. When I write the value of mu1, it will be c divided by v1. So basically it becomes V1 divided by V2, where V1 is the speed of light in medium 1 and V2 is the speed of light in medium 2. Do we understand this?
Yes, sir.
This is the concept of relative refractive index. Relative refractive index of one medium with respect to the other is refractive index of the first medium divided by the respective index of the second medium. I'll give you a minute to note it down and I will be back after that. Let us go back to the statement, the second law of refraction. And remember, this law of refraction, I forgot to tell you whether you write it in way number 1 or way number 2. This law is known as Snell's law. Will you remember this name, Snell's law?
Yes, sir.
Whether you write it as number 1 or number 2 or number 3 all mean the same thing. This is known as Snell's law. Now, now we have studied the term relative refractive index, and here I have mu r by mu I. Now I can extend this law and write it in different ways. One more way, so I can write it like this: sin I by sin r is equal to mu r refractive index of r divided by refractive index of I. Now I have understood the meaning of the relative refractive index. Now how can I write this in terms of relative refractive index? Can anyone tell me what will be the symbol I will be using? I can write it as mu of r here with respect to I here. Do we understand this? And this one will be equal to speed of light in the incident medium divided by speed of light in the refracted medium. And then what I'm going to do is put everything in a bracket, whether you write it in number 1, number 2, number 3 or number 4, everything here is Snell's law. What you can see on the numerator, we have sine of I. On the second numerator, we have mu of r. On the third numerator, we have speed of light in that medium. In the denominator, if I talk, we have sine of r blue. In the second column, we have mu of I. In the third one, we have speed of light in the second or the refracted medium. All this is known as Snell's law. Whether you write it in the pink way, which is way number 1, either you write it in the blue way, which is way number 2, or you write it in the dabba wala way, everything is same. Do we understand this?
Yes, sir.
I'll give you a minute to note it down and I'll be back. Well, then I'm back. And now
Yes.
we'll try to understand why does light bend. Now, it is explained here in notes, but I will just simply write what I have written in the sheet before. I had written this sine I by sine r, and I will write the entire thing is equal to Vi by Vr. Yes or no? Do we remember this?
Yes, sir.
Then now see, and that is equal to mu of r divided by mu of I. Yes or no?
Yes, sir.
Then sir, see sir, if V of I is greater than V of R, that means speed of light in the incident medium is more than the speed of light in the second medium, the refracted medium. That means light is going from rarer medium to denser medium. Do we understand this?
Yes, sir.
If speed of light in I is more than speed of light, the light is going from rarer to denser medium, then you see, bacha, what will happen? Sine of I will be greater than sine of R, or I will be greater than R. I will be greater than R. That simply means that the ray angle of incidence is more, angle of refraction is less, and the ray will bend towards the normal. How do I remember this? I remember this by this short form RDT. R standing for rarer medium, D standing for denser medium, T standing for towards normal, RDT stands for rarer to denser medium. It will bend towards normal. Do we understand this?
Yes, sir.
This is how we understand it in terms of language. I will give you a minute to note it down. Remember the three letters. What are the three letters that you have to remember?
RDT, sir.
Yes, sir. And there is a problem with my highlighter, sir. RDT, sir, is what you got to remember. From rarer to denser medium, the light will bend towards normal. That are the three words that you must remember and never forget. Everything that I'm telling you is already there in your sheet. And this is the diagram that we are referring to. And I will show you the diagram now on your screens. And here it comes on your screen. I think you can see it on your screens. So basically, this is the diagram that we are talking about. Light is going from rarer medium to denser medium. This is the rarer medium, the incident medium. This is the denser medium. And as you can see, sine of I is more than sine of R. That means I is more than R. And the light is bending towards the normal. This is bending towards the normal. Therefore, the three letters R, D, and T. I'll give you a minute to remember these three letters, and I will be back after that.
Okay, sir.
Well, then, if you have noted it down, I am back. From rarer to denser, it bends towards the normal. Then there is no point of wasting any time in understanding that if it goes from denser to rarer, dr, if it goes from denser to rarer, then what will happen? It will bend away from the normal, and this is how I remember it. DRA, from denser to rarer, it bends away from the normal. And again, I can't get my okay, it is working now. From denser to rarer, it moves away from the normal. Do we understand this? DRA, you just have to remember one. I remember the first one, RDT. I don't know why I can't remember DRA, but you remember it as RDT or you remember it as DRA. It is the one and the same thing. So when it goes from denser medium to rarer medium, the speed of light in denser medium is less, the speed of light in rarer medium is more, and hence the light ray will be bending away from the normal. Everything is given in your sheet. I am just showing a part of it, part of the diagram that is already there. And this diagram clearly illustrates the three words that I am talking about, the three letters that I am talking about. Here, the light is moving from denser medium D to rarer medium R, and it is moving away from the normal D, R, A, these DRA. These are the three terms that we must remember. Do we understand this? I'll give you a minute to note it down. Let us move ahead in life. Mics may come and mics may go, but the life has to move on. The next heading that we are going to write is apparent debt and real debt. Apparent and real debt. Apparent and real debt. Now, what is this? What does this mean? You will see a lot of different formula in different books. You might get confused a lot. Now, what is this apparent debt and real debt? For example, if you have a coin placed on the bottom of a beaker or a bucket containing water, you will see when you are seeing it from air that this coin will appear a lot higher than it actually is. Have you noticed this down? If you're looking at something which is inside water, it will appear that it is nearer. Do we have we seen this? Yes or no? If you are in air and you're looking at something inside water, it will appear that it has shifted up. Yes or no? Yes, it will appear that it is shifted up. Now, it appears that it is shifted up. Whatever depth we see is known as the apparent depth. Whatever depth we actually see is known as the apparent depth. What is the actual depth is known as the real depth. Now, why this happens, I will just draw a diagram. For example, this is the boundary. On one side, we have air, and the other side, we have water. And this is the normal. Let us say that there is a coin here, and you are trying to watch it. You are trying to watch it from outside. Now, let us say a ray of light is going like this, striking here at an angle of incidence I. Now, this is the real depth, dr. This is the actual depth. This is the actual depth, dr. Now, when it goes from water to air, water is denser, air is rarer. So what will happen is that it will bend away from the normal. Do we understand this? This is R. Do we understand this? Now, if I retrace this R, the object which was original object was O, the object will not appear at the point O, the object will appear at the point O dash. Yes or no? This depth of the point O dash is known as apparent depth dA. Are you getting my point, bacha? dr is the real depth, dA is the apparent depth. Are you getting my point? And the distance between O and O dash is known as the shift. This is known as the shift. How much it has shifted. And this is nothing but D real minus D apparent in this case. So when light is going from rarer medium, as you can see here, the blue medium is rarer medium and the red medium is denser medium. The object will appear closer. Do we understand this? The object will appear closer. Do we understand this? Can I have some raise hand that we understand this? Okay. Okay, now your video has paused. I mean, are you there in the class? Or have you got disconnected? Okay, you are there in the class. So now to get a formula that relates, and again, I don't want to confuse you. I have to relate the four terms, and the four terms are dr, dA, angle of refraction, and angle of incidence. I have to relate these four terms in terms of rarer medium and denser medium. Now there are different formulas. The one formula is also given in your sheet. You can always go through that formula. But my formula is somewhat different, because this formula is valid whether the light goes from rarer medium to denser medium, or where the light goes from denser medium to rarer medium. In the sheet that you have, that I've sent you, the formula, there are two formulas given. If you can go through the sheet, there are two formulas given. One formula is for rarer to denser. The other formula is for denser to rarer. And I hope and I feel that since there are two formulas, you might get confused. So instead of giving you two formulae, I am just going to give you one formula, and this formula is valid whether it is rarer to denser or denser to rarer. Do we understand this? Raise of hands will tell me that we understand this. So what do I do here? I take the blue quantities, and the blue quantities are dr and I and mu I. Do we understand this? There are three blue quantities. Real depth is the depth in the incident medium. Mu I is the refractive index in the incident medium. Do we understand this? So I take the ratio of these two. This is not a ratio. dr divided by mu I. dr divided by mu I. These are the two terms I have taken from the incident medium. Then I have the red medium. In the red medium, I have dA, I have R, and I have mu R. These are the terms in the refracted side, because apparent depth is the depth that I see from the refracted side. So I take the two terms from there. That will be equal to D apparent divided by mu R. Now from here, you can find the value of dA in terms of dr, and what is the answer that I will get. Remember this answer, this formula is valid whether you are going from rarer to denser or you are going from denser to rarer. D apparent, oh, I should use a different color, otherwise it will get confusing. I'll use a black color. D apparent is equal to mu r, the second medium, divided by mu I, the first medium, multiplied by the depth in the first medium. This is how I remember it, and this is how I hope that you remember it. That you remember it. That you remember it. That you remember it. I'll give you a minute to note down this formula. Remember, the formula given in your sheet is also correct, but there are two formulas given, one for rarer to denser, one for denser to rarer. Will create a lot of confusion. I don't want confusion in my life, nor yours. This is one formula which is valid everywhere. I'll give you a minute to note it down. Okay, then if you noted it down, then I will just elaborate more. Case number one, the light is going from rarer medium to denser medium. It is going from rarer medium. The first medium is rarer and the second medium is denser. this simply implies that from rarer to denser, mu r will be greater than mu I. Do we understand this? We understand this, then this implies that apparent depth will be more than the real depth. That means if something is placed in air and you are seeing it from water, it will appear farther away. Yes or no? Great, great, great. In that case, x, which is the shift, and if you can see in the previous diagram, I have written shift x. Do you see this shift x, which is I have painted in pink? Do you see this shift x? Do you see the shift x? This shift x can be written as dA minus dr, because here apparent depth is more and real depth is less. Do we understand this? This is the case when light goes from rarer medium to denser medium. Remember the formula remains same. The formula for apparent depth is always equal to refractive index of second medium divided by refractive index of the first medium multiplied by the real depth. The formula remains same. I can now write the formula. I can now write the formula for case number 2. For case number 2, it is going from denser medium and it is going to the rarer medium. That means your mu r is less than mu I. It is going from denser medium to rarer medium. It is going from water to air. In that case, you will see from the formula that apparent depth will be less than your real depth. The object will appear smaller. X, which is the shift in this case, since apparent depth is less, real depth is more, you will calculate it from the formula dr minus dA. Do you understand the difference between the two formula of number 1 and formula number 2? The only difference happens because one is more, other is less. Even if you don't take that difference, you always do dA minus dr or dr minus dA. One answer will be positive, the other answer will be negative. The value of apparent depth, the formula of apparent depth still remains same. It is refractive index of second medium, which is divided by refractive index of first medium multiplied by dr. Do we understand this? Can I have some raise hands from everyone that we have understood this? One formula which is valid everywhere, not 2 or 3 or 4 formulas for different cases. One formula everywhere. That's how I always understood, and that is how I am going to make you understand. I'll give you a minute to note it down. Now is the time that we apply what we have seen or what we have understood till now. So this is the question where we are going to apply this. A tank is filled with water up till a height of 12.5 centimeters. So I filled the tank with water. The apparent depth of a needle lying at the bottom, how high or how deep it is looking, is measured by a microscope, very precise. 9.4 centimeters is what I see. The first question is, what is the refractive index of water? So you have to first calculate the refractive index of water. The second question is, if water is replaced by a liquid of refractive index 1.63, what will be the apparent depth? So there are two questions here. In the first question, the apparent depth is given and mu is to be calculated. In the second question, mu is given, apparent depth has to be calculated. In both the cases, the real depth is 12.5 centimeters. Do we understand the question, everyone? Can I have raised hand that we understand the question? If you don't understand the question, there is no point of doing it. Do you understand the question? Yes or no? Okay. I'll give you a minute to solve it. So here is how you have to solve it. Real depth is given as 12.5. Apparent depth is given as 9.4. We just put the formula for apparent depth. Apparent depth is equal to real depth into refractive index of the second medium, mu r, divided by mu I. Is it clear to everyone which formula I have used? The mu r, the second medium from which I am seeing it, is air. The refractive index of air is 1. Do we understand this? I just put the values. D apparent is 9.4. D real is 12.5. I can get the value of mu I. Mu I is basically the refractive index of that medium, which is water. So mu I becomes, just need to cross multiply, dr divided by dA. dr is 12.5 divided by 9.4. That is your answer for the first question, and it will come as 1.33. Do we understand how I have done this? I'll give you a minute to note it down. After that, I will solve the second part of the question. I will also give you time to think about the second part of the question. You can solve it on your own. That is excellent. I'll be back in a minute. Now let us move on and solve the second part of the question. For the second part also, dr, the real depth is 12.5. Do we understand this? Can I have some raised hands? You have to find out the value of apparent depth, dA, which is the question mark. So I'll write it as question mark. The refractive index of the second medium is air, so I will take it as 1. Remember, vacuum and air, the refractive index is taken almost same, it is 1. The refractive index of the first medium where you have placed the needle is given as 1.63. Now I will use my formula, and my formula remains same. D apparent it is equal to D real into mu r divided by mu I. Remember, this formula is valid for all the cases. dr is given as 12.5. I will put that value. Mu r is given as 1. Second medium is air. Mu r is given as 1. The third, gentleman, is your mu I, the blue one, which is 1.6. I put the values here. D apparent becomes 12.5 multiplied by 1 divided by 1.63. I solve this and I will get 7.67 as the answer. Do we understand this? Are we solving the question or are we indulged in our own little things? Do we understand this? Can I have some raise hand that we understand this? Yes or no? Okay, I'll give you time to note it down. I'll give you time, a minute, and I'll be back after a minute. Now let's begin with this, which is known as the lateral shift. What do you mean by lateral shift? Let us suppose that you have a medium, let us say air, and you have a glass slab. What is a glass slab? Nothing. I mean, a block of a cube of ice, or a cube of glass, and light is traveling. So it is going from air to, let us say, glass, and then it is back into air. So you are watching something through a glass slab. Do we understand this? Watching something through a glass slab. Now when you are seeing something through a glass slab, there are 2 points that you must remember. There are 2 points that you must remember, and they will come as question in your exam. This ray number 1 is known as the incident ray. Do we understand this? Ray number 1 is the incident ray. Do we understand this? Yes or no? Can I have some reason that we understand this? Okay, ray number 2 is the refracted ray, and the refractive index of this medium with respect to air is mu. So ray number 2, the red ray, is the refracted ray, and I am going to draw the third ray, which is the black ray. The black ray, the third ray, the third ray is known as the emergent ray. And if I draw E, as you can see this E, and I will just do what? I will just enhance the diagram. This diagram is from your sheet only. I will just enhance the diagram so that you can see what I am drawing here. Diagram comes on your screen now. I hope you can see it, right? So ray number 1, the blue ray, is your incident ray. Ray number 2, the red ray, is your refracted ray. Ray number 3 is your emergent ray, which is coming out. I is the angle of incidence. You can see that. R is the angle of refraction. You can see this R, angle of refraction. Yes or no? Please raise your hands. You can see this I, which is the angle of incidence. Yes or no? And then there is E, which is the angle of emergence, or 3 is the emergent ray. Remember, this angle I, which is the incident angle, is equal to the emergent angle. That is the first thing that you should remember. The angle of incidence and the angle of emergence is equal. The angle of incidence and angle of emergence is equal. The other way of saying this is that the incident ray and the emergent ray are parallel. So that is the first point that you must remember here. I hope you have seen the diagram from the sheet and you have drawn it. The first thing that you must remember, and I'm writing it down, the angle of incidence is equal to the angle of emergence, which implies that incident ray is parallel to the emergent ray. Have we drawn this? Yes or no? No or yes? Angle of incidence is equal to angle of emergence. The incident ray is equal to the is parallel to the emergent ray. Do we understand this? Can I have some reason that we understand this? Please note it down. Please note it down in your sheet. Please note it down in your sheet. Please note it down in your sheet. The angle of incidence is same as the angle of emergence. That is what you got to remember. That is the first thing. Now, once you have understood this, then the second thing that you got to understand is that the emergent ray, the emergent ray is shifted. The emergent ray is shifted parallelly. The emergent ray is shifted parallelly, and this shift is known as lateral shift. The only thing that happens is that the emergent ray shifts parallelly, and this shift is known as lateral shift. This is the heading of this. The lateral shift is nothing but the shifting of the emergent ray. Do we understand this? Can I have some raised hand that we understand this, that the emergent ray is shifted? I hope you are noting it down. Please note it down. I'll give you a minute. I will give you a minute to note it down. The emergent ray is nothing but it is parallel to the incident ray and it has shifted. I'll give you a minute to note it down. Now, since we have seen that the emergent ray shifts parallelly and this shift is known as lateral shift, and I hope you can see that diagram here again. The diagram has been rubbed off. Can anyone tell me? You can see some things on the diagram: A, B, C, D, mu, I, R, I minus R. Can you tell me what is the shift in the ray? Again, I will mark down the ray. This is the ray number 1, which is incident ray. This is ray number 2, which is your refracted ray. And this is ray number 3, which is coming out, which is the emergent ray. As you can see, and I will mark it, the incident ray and the emergent ray are parallel to each other, but the emergent ray has shifted. As you can see, I have drawn a line which tells us the actual path of the first ray, which is the incident ray. Do you see that actual path? If there was no glass slab, it should have gone straight. Yes or no? But right now, it is not going along that path. As you can see, it is going along the path of the third ray. It has shifted by some amount. And can you see this amount by which it has shifted? It has shifted parallelly. These two rays are parallel. It has shifted parallelly by an amount D. Do you see that amount D? Yes or no? Do you see that length D? That is known as the lateral shift. That length D is known as the lateral shift. I hope you have marked it in your sheet. Yes or no? Have you marked it in your sheet? Please mark it in your sheet, and then what you got to do is mark this formula in the sheet as well. And this formula, you will have to remember it as it is. You will have to remember this formula, and this formula comes on your screen right away. The value of the lateral shift D. The value of lateral shift D is T. Now, what is this T? This T is the original thickness. This T is the original thickness, the original thickness, the original thickness, the original thickness of the slab. R is the angle of refraction. I is the angle of incident. And this is the formula that you must remember. D is equal to T by cos R into sine of 1 minus R. I hope you have noted it down. Your camera seems to be off. Okay, it's here. Can I have some raise hand that we have written this? That is what. I'll give you a minute and then we'll come to the last part of today's class. Now is the time that we look at one more thing. What is that one more thing? Up till now, what we had seen is that this is the incident ray, number 1, and this is the emergent ray, number 3. And we had seen that the emergent ray shifts parallelly, and we had seen how much is shifted, yes or no? Now what we are going to see is, if you have an object over here, object is O, and I'm watching, my eyes are here, and I'm watching this object from the other side of the slab, this object will not appear where it actually is. It will appear shifted. So this is the eye or the image that I see, and I will again enhance this diagram so that you can see it on the full screen what I am talking about. And I hope that you can see it now on your screens. I is the incident ray, E is the 3 is the emergent ray. I have my eyes on the other side of the slab. I have an object placed at the point O, and what I see, the object will not be at point O. I will be seeing it at point I. This point I is the image of the object that I see. And as you can see, this image had been shifted towards the slab. So that is the first thing that you must remember, that this image is shifted towards the slab. Will you remember this? Whether the object is placed on this side, whether the object is placed on the other side, wherever the object is placed, the object is always shifted towards the slab. Do we understand this? Can I have some raised hand that we understand this? The object is always shifted towards the slab, and how much amount the object has shifted, that is the value of x. Do you see x here? Do you see x in the diagram? Yes or no? Please raise your hands that you see the x. The x is the amount that this object has shifted. And what is the value of this x? The value of this x is d upon d multiplied by 1 minus 1 by mu. This is the shift in the position of the object when the object is seen through a glass slab. I will show you the formula. I will show you the formula in big picture, in big screen. The shift x, which is the amount that the object seem to be shifted, is given by this formula d. D is the depth, the actual width of the slab. Mu is the refractive index of the slab, and this is the amount by which the slab by which the object is shifted. And you must remember that, and you must remember what? And you must remember that this x is always, this x is shifted always, this x is shifted always towards the slab. This x is shifted always towards the slab. You might get a direct question on that. Please remember this. Please remember this and note it down. Taken from your sheet, you can mark things on the sheet and you can just write this information in the sheet. The amount x is d into 1 minus 1 by mu. D is the thickness of the slab. Mu is the refractive index of the slab. And this x is shifted towards the slab. Have you noted this down, everyone? Well, with this, we come to an end of today's class. What we have done in today's class? In today's class, we have seen what is refraction. When light goes from one medium to the other medium, it bends. Sometimes it bends towards, sometimes it bends away. When it's going from rarer to denser, it is bending towards. From denser to rarer, it is bending away. Because of the difference in the speed of light, in denser medium, speed is less. In rarer medium, speed is more. The fastest speed is in vacuum or air. The refractive index is 1. That is the rarest medium. All other mediums, refractive index is more than 1. You can find the refractive index of one medium with respect to the other medium. Refractive index of 2 with respect to 1. R with respect to I will be mu R by mu I. We have seen the laws of refraction. Snell's law we have seen. Sin I by sin R is mu R by mu I is equal to Vi by VR. When light goes from rarer to denser, it bends towards. When denser to rarer, it bends away. Therefore, we see apparent shift and real shift. apparent depth and real depth. We have also seen the formula for apparent depth. D apparent is D real into mu r, second medium, divided by mu I, the first medium. We have also seen what happens when light passes through a slab. The incident ray and the emergent ray, they are parallel to each other. Incident angle and emergent angle, they are same, equal. Incident ray is parallel to the emergent ray, but is shifted by an amount which is known as the lateral shift. D is the value of lateral shift. T upon cos r, T is the thickness of the slab, T upon cos r into sine of I minus r, I is the angle of incidence. You've also seen that if you have a glass slab and you have an object on the other side of the glass slab and you are watching it from the other side, the object will be shifted. The amount of shift x will be d, thickness of the slab into 1 minus 1 by mu. We will start our next class from this note. I hope you have understood this class, and I'll see you tomorrow, same time, same place. Take care and have a nice day. Bye bye.